Okay, this is the analytical geometry part of the rescue plan, and we're going to do just the essential stuff. And if you know the essential stuff, you're going to pick up lots of marks in this section. So here we go. You're given all these formulas. Now we're going to use everything here, and circles. We're going to use everything here just with these 2 points. A is -3 and 2. B is 2 and 1. Okay, say you are asked to determine the midpoint. Well, you can do it if you know the midpoint formula, and there it is. You add the x values and divide by 2, add the y values, divide by 2. Well, there's the y values. 2 plus -1 divided by 2 is 1/2, the y coordinate of your midpoint. And let's try the x ones. -1 plus 2, -3 rather, plus 2 is -1 divided by 2, it's -1/2. There are the coordinates of the midpoint of AB. Okay, let's try the gradient of AB. Well, you have to know that's the formula for gradient. That's the formula for gradient. We're going to subtract the y values. 2 minus -1, that's 2 plus 1. So I get 3 on top. And then -3 minus 2, I get a -5 on the bottom. Well, a positive divided by negative gives you a negative gradient of 3/5. Makes sense because it's going downhill. Let's try the next one. Determine the length of AB. Determine the length of AB. Well, there's the formula. I like to look at d squared, though. AB squared. I don't have to write that long square root thing down. I just subtract the x values, -3 minus 2, and put a bracket in your calculator. So you'll get 25 when you do it. If you don't, you can often get the wrong answer. Then the change in y, 2 minus -1, that's 2 plus 1. See, just like that, just follow the formula. 25 plus 9 is 34, but that's what AB squared is. But you just take the square root to get the length. If they say determine the angle of inclination, that's this angle here, theta, figure out what that angle is. Well, there's the formula. If you've got a gradient, you've got the angle by just going shift tan. So if they ask for an angle in these questions, just go shift tan of the gradient that we figured out, -3/5. You'll get this negative angle, but we want this big angle here. We add 180, and we get the answer, 149.04 degrees. They might just ask, determine the equation of the line. Well, there it is. That's the point gradient form of the equation of a line. Well, we've got the gradient. It's -3/5, so you put it in there. You might get a mark just for doing that. And then we're going to put in the easy point with the small numbers. We put in -1 there. -1 makes +1. And then we put in -2 because we're subtracting 2. We put a 2 in there. There's the equation of the line. We're done. We just have to multiply it out a little bit. -3 times -2 is +6/5. We take away 1, and it's 1/5. 1/5. So there's the equation of the line. What if they said, determine the equation of a perpendicular line right at that point A? That green line is 90 degrees, say. Well, perpendicular means the gradients multiply to equal -1. So all you do is turn it upside down and change its sign. And then it would multiply to equal -1, the gradients. So there's the gradient we put in. We want to find it right at the point -3 and 2. So there's y minus y1 is 2, and x minus -3. So that turns into a +3. Well, 5/3 times x, 5/3 times 3, the 3's cancel, you get 5, and then add 2, and that makes sense why you would get that 5/3x plus 7 is your final answer. Okay, let's just try the last thing with a circle. Say you were given this picture here, and we're using A and B. Say I use that line, and I said B was the center. B was the center, and B is -2 and 1. And I made a circle, a radius, all the way around. And then there was a tangent line at A, right here, a tangent line at A. Okay, the first question might be, determine the equation of the circle. Well, there's the equation of the circle. The center is minus 2 and 1. That's your A and B. That's what's going to go in there. So just put minus 2 in there. X minus minus 2 is X plus 2. That's your answer there. It's so easy. And then 1 is B. So you put 1 in there. Y minus 1. That's it. And what is the radius? Oh, it's root 34. So AB is R. AB squared, the radius squared, is 34. Oh, we had that before. So we just rub out the R squared and put 34. There's the equation of the circle. Now, what if they said determine the equation of the tangent line at A? Well, you'd go, hey, that tangent line is perpendicular to the radius. That's a geometry reason. So AB is perpendicular to the tangent line. We know that the gradient of AB, and if you had this question, you'd have to figure it out, is minus 3 over 5. So the tangent line gradient must be 5 over 3. And we put it into that gradient point formula. And we want to do it right at A, so we go x minus minus 3. Hey, we've done this before on the other page, the perpendicular line. We've done it. We put in the A value. We put in the A value. Make it a little bit better here. We put in the gradient, and we put in the coordinates for A. Minus minus 3 is plus 3. Minus 2 for the y. That's your answer. And we've done this before. 5 over 3x plus 5. 3 times 5 over 3. And then add 2. There's the equation of the tangent line. Well, that's the essential stuff we have to know for analytical geometry.